you able to unmute and switch your camera on, that would be brilliant. Thank you. Good morning. Thank you. Okay, Fumi, over to you.
Yeah, it's my pleasure to introduce Mariano. Dr. Mariano Felice is Senior Research and Data Scientist for Language Assessment and Learning at the British Council, where he leads their AI strategy. His work focuses on applying natural language processing to assessment, supporting the responsible development and the use of AI, and promoting AI literacy. With over a decade of experience, he has published numerous scientific papers in top-tier NLP conferences, and he is a regular speaker, actually guest speaker at international conferences. He's also visiting scholar at the University of Reading and the University of Cambridge. Mariano is not only an excellent researcher, but also a fantastic speaker. So we are very much looking forward to his talk titled Bringing a Digital Chatterbox to Life, Lessons from Building an AI Speaking Assessment Platform at the British Council. Mariano, the floor is yours. Over to you.
Thank you, Fumi, and good morning, everyone. It's an honor for me to have been invited to this CRELLA Annual Lecture and be with all of you here today. Let me share my screen. So hopefully you can all see that now. Great. So as Fumi mentioned, I am a senior AI researcher at the British Council. And in this talk, I'm going to tell you a bit about how we built a chatbot as part of a speaking practice and assessment platform called AIBC that we developed at the British Council. AIBC has two sides to it, the practice side and the assessment side, but today I will be focusing only on the practice side, which actually involves creating a chatbot that drives the conversations that the users have. So this chatbot is what I call the digital chatterbox, as you will see that it speaks a lot sometimes. So this is actually the story of how that chatterbox was brought to life, how it was nurtured, and the lessons that we learned along the way. Okay. So let's start from the beginning, actually, from the origin of this chatbot's life. So as I mentioned, our chatbot is the core component of the conversational side of AIBC, the speaking assessment platform that we created at the British Council. And the idea behind AIBC is to provide goal-oriented, interactive, and multimodal tasks at different CFR levels. So unlike most other AI speaking platforms out there, you practice your speaking skills in the context of a task that has goals and makes you practice specific language functions. So you actually speak with a purpose. Now, building a complex platform like this, where you need to integrate many things from task design and assessment theory to technical capability and even things like ethical principles, you actually need to build a multidisciplinary team and spend a lot of time working together. So AIBC actually took a long time to develop. It took many years to come from an original idea to a fully fledged product. And I say there's still a lot to be done, as you will see during the talk. But I think this is also what makes the process of creating this chatbot so rich. You have insights from people with different perspectives, and that is crucial to identifying things that we need for this chatbot, what things could go wrong, how things could be fixed. And these are things that we probably would have missed if we hadn't had such a multidisciplinary team. So after many ideation and brainstorming sessions, we came up with a list of requirements for a chatbot and started to get our hands on it. So, as I mentioned, we started gathering the requirements that we needed for this chatbot, and we also needed to collect the resources that we needed in order to build this initial prototype that we had in mind. So this includes things like people, the right people, technical teams, researchers, academics, and so on, that we all had to get together to come up with this initial version of the bot. Now, the requirements that we identified early on were quite basic and also very clear, actually. So let me show you what these were. So we identified that this initial chatbot should have three core functions first. So it had to have the ability to listen, it had to have the ability to think, and it had to have the ability to speak. Now, we also needed to identify how we were going to implement each of these functions, and I'm going to walk you through them now. So let's start by listening. So by listen, we mean giving the bot the ability to listen to the user, receive audio input, and generate a transcript. So this is something that we do using an automated speech recognition model that you probably know already. So these are systems that take voice as input and produce a transcript. They produce the text representation of what you've said. Then when we think about the think component, what we mean here is being able to process that input, that audio and transcript that we generated in the previous step, so that the bot can understand what the user said and can generate an answer. So in a way, this component is the brain, so to speak, of the bot. And there are different ways in which we can implement this brain, in which we can build this. So one way would be, for example, to have a predefined script or have rules or decision trees that tell the bot exactly what to say given certain input. Although this kind of brains are very rigid and very limited. So nowadays we use things like large language models, LLMs, that give you a lot more flexibility and allow us to have unscripted conversations that are also context sensitive. And finally, I mentioned that we need to give the bot the ability to speak. And by this, I mean turning the answers that the bot generates into a spoken response. And the way that we do that is by using a text-to-speech model, or something that we also called speech synthesis. So those kind of models we use for making the bot speak. Now, I'm going to go through some of these components in a bit more detail, as I think there are a few interesting things to talk about. So we're going to be looking at these in more detail throughout the rest of the talk. Okay, so after working on this, on putting these components together for some time, our bot finally comes alive. And it has the ability to listen, think, and speak, but it is very limited. In fact, this early version that we created has quite a few limitations. So, for example, it has a very flat voice. So this is because we originally used some embedded capabilities in the browsers that were used to deliver the platform. Then it was also very slow sometimes. So it took quite a bit of time for the bot to react and to process the input. And finally, because we didn't quite figure out how to make LLMs work in this initial prototype, the answers were very scripted. The conversation felt very structured. So this wasn't really what we had in mind. But this was what we could do with the limited amount of time that we had. It was something like a few months, really, to put everything together. Okay. So before we went any further into developing a fully fledged solution, we had to look at the implications of building this kind of tool, this kind of robot. And that's when we realized that we needed an ethical framework that would guide us through the development process. Now, the problem was that we were no experts in this domain, so we had to get expert advice. So that is where we landed in the UCL Knowledge Lab and their group of experts in ethics of AI in education. So we got together with them. We had a plan for a few months to get together, have a couple of sessions, write documentation, learn about legislation, what ethical frameworks were out there, so that we could incorporate all those notions and ethical principles into how we built this platform. And as you probably know, the British Council is really committed to responsible AI, and we take EDI, for example, very seriously. So this was something that we really wanted to do before we went any further into developing our bot. So as I mentioned, we worked together with UCL. We came up with a framework for using ethics, embedding ethics into the development and use of the AI systems that we incorporated into our platform. And a result of that process was a position paper that we wrote and is out there that actually explains the principles that we follow in not just in AIBC, but in all the AI-powered products that we have at the British Council. Okay. So we mentioned earlier that one of the first things that our bot needs to do is to listen, learn how to listen. So here we need to do two things that I already mentioned. We need to actually capture the audio, so what the user says, so that we can then assess things such as pronunciation, fluency, intelligibility, and so on. But we also need to produce a transcription of that speech so that we can assess things like grammar, vocabulary, coherence, and so on, things that we need to assess from the written text of what has been said. However, this aspect, the listening aspect, is one of the most challenging components because there's a lot of variation in the way that people speak, and that means that systems are not 100% accurate transcribing, and that's especially the case for non-native speakers of a language. So there's not only that factor, but also other issues, for example, around background noise or poor quality audio and so on. So these are all things that we need to take into account when we process the audio. So we need to build this in a way that is the most robust and accurate as possible. So I'd like to talk about all these things in a few more detail. Because there are lots of implications of what we get from this audio input, and any errors that are in this input will then be propagated to the rest of the components in our bot, in our platform. So the first thing I'd like to mention, as I was explaining earlier, is the issue that there is around the transcription of L2 learner speech, so non-native speech. So as you can imagine, most of these ASR systems that are out there, most commercial systems, are built from mostly native speech. They also have a proportion, I would say, of accented speech and also a proportion of non-native speech, but the majority of the training data that's used for these models actually comes from native speakers. And the way that we analyze and evaluate the accuracy of a model in order to choose which one is appropriate for a platform is by using a metric that is called word error rate, that basically tries to quantify the difference between an automatic transcription produced by an ASR model and gold standard transcription that's produced by a human. So whenever we evaluate an ASR system, we do it in terms of this metric. This means, obviously, that we need to have an annotated data set with gold standard transcriptions that we can use to assess the accuracy of the model. And what I'm showing you here in this slide is the variation that you can see when you evaluate models on native speech, in this case, American English, but also on accented speech for speakers of different L1s. So you can see there's a lot of variation and a lot of degradation of the accuracy of the results. Because we're talking about error here, obviously the lower the bars, the more accurate the models. So as you can see, the bars go much higher up for non-native speech. This is something that we need to take into account. Then, as I also mentioned, we have to be very careful about errors, mistranscription errors, and this is because, as I said, all the errors that come from this input will then propagate to the rest of the components and will have impact on the way that we assess speaking ability, for example. And what I'm doing here is showing you some transcription errors that we see in some of the models of a very capable commercial model that's considered the state of the art nowadays. And you can see how there are certain words like, for example, the mistranscription of the word chart, probably because the learner wasn't able to produce this word accurately, how that gets transcribed into a completely different word. Then we see, for example, in the case of can't, in the middle of the image, how that was wrongly transcribed. Instead of can, it transcribed can't. So actually that changes the meaning of what the learner is saying. And then we have another word there that's probably a confusion of two other words. Probably the learner wanted to say this course, and the ASR model interpreted something completely different. So what you can see there as well is in different colors, you can get an idea of the confidence that these models have in generating each of these words. So every time that an ASR model produces a word, the transcription of a word that somebody has said, this comes with a confidence score. And perhaps we can use this confidence score to map out how accurate the system is and maybe make certain decisions about what areas of this transcription we can rely on and which ones we can't. Something else I'd like to show you, again, in terms of the metrics that we use to assess the performance of ASR models, is how error varies when we do transcription, as we call it, when we do transcriptions, say, offline in a batch process, or when we do transcription live. So in general, if you use any service to transcribe an audio clip, that is generally referred to as batch transcription. So you basically send audio to an ASR model and then just wait for the results. And when the results are ready, you get your transcriptions. This is the usual way that people do it. And this is the way in which you can get the most accurate results. However, in the context of a real-time speaking platform, we need to do what we call streaming transcription or live transcription. So what this means is that the ASR model is constantly listening in the background to what the user says and is transcribing word by word. So the problem with this approach is that because it has very limited context and it has to make decisions very quickly on the spot, the quality of the transcriptions are not as good as if you were doing batch transcription. And what you can see there is how the error goes up when you do this live transcription for a number of state-of-the-art commercial models. So there's also this impact of using a live transcription service that also creates issues when we transcribe text. Now, the other component that we also need to talk about is giving the bot the ability to think. So we need to give this bot a purpose. We need to tell it exactly what it has to do when it has a conversation with a user, how it's going to interact, and so on. So for this, we use a large language model. which I'm sure that you know what they are at this point. We're talking about things like, for example, ChatGPT or Google Gemini and so on. We could have a much simpler model. As I mentioned, this could be a scripted conversation, or it could be a decision tree, for example. But nowadays we have these great large language models that give us the ability to give more precise instructions and have structured conversations and conversations that actually are more context sensitive. So the way in which we tell a bot what to do is through a prompt. And a prompt is basically a set of instructions that we write in natural language, in human language, that explicitly tells the model what it has to do, how it has to speak, how the conversation should go, what the structure of the conversation is, and so on. Now, in the context of AI-BC, these prompts have to be very specific because the tasks that we want the users to complete are goal-oriented. So they have to have a purpose. They have to have a very specific structure. So this is very useful. Specifying this structure is very useful because otherwise the bot will start going astray and will do whatever it wants. So we have to be very specific about how the bot should be doing things. And here I'm showing on the screen the kind of information that we include in every task prompt that we use to specify each of the tasks that we have in our platform. So we have a section, for example, where we specify the persona of the bot. So things like whether it should be a friendly interlocutor, the kind of language that it uses, some traits about its personality, and so on. We also specify things around the situation, the context of the task. What is it that the user needs to do in the task? We also specify some success criteria. So what is considered a successful interaction? And finally, we provide more details about the task, so very specific things about the task, like, for example, information about the input material and so on. And we include some instructions about how the conversation should go. So, for example, if the conversation has different stages and what needs to be discussed at different points throughout the conversation. And because we have to do this many times for different tasks and so on, this means that we really need to crack how we do prompting, and we really need to start mastering the art of prompting, so to speak. So as you probably know, the process of writing these prompts and tweaking them is called prompt engineering, and this is an essential part of writing successful prompts. And when we do this in the context of AI-BC, in the context of creating goal-oriented tasks, as I mentioned, we have to be very specific. So we came out with a pipeline of processes that we always follow whenever we want to create a new task and the prompts that go with those tasks. So this is what you can see on the screen. This whole process takes you from the specification of the task to creating the materials, trialing that task with users first without implementing anything with an LLM. And then you finally move on to creating the prompts for the tasks. You collect feedback on how this task is working now with the LLM, and you refine prompts accordingly. So this is the process that we always follow whenever we create a new task. Now, the last thing I want to mention, and this is the last component that I mentioned earlier, is the ability of the bot to speak. So we need to give this bot a voice. And the way we do that is by adding a text-to-speech or speech synthesis module. Now, you probably know that there are many services out there that will generate a voice, will generate audio from a written piece of text. And yes, you have many services out there, but you have to be very careful about the kind of voices that you choose in the context of a platform for non-native speakers of English, for learners, especially at different CFR levels. So you have to take into account things related to the voice features, whether the voice sounds friendly, whether it's properly spaced, whether the cadence is good, and so on, whether the voice is clear. So all these features related to the voice itself and prosody and so on. Then obviously we need to take into account things related to cost, how much it is going to cost to generate this audio. This is something that we also need to consider for the rest of the components. And the speed, or rather the latency that there's going to be between generating the written response and generating the corresponding audio of that response. And sometimes what we found is that if we don't like any of the voices that are out there, we always have the option of cloning voices, and this is something that we have also been experimenting with. So this is also another avenue that you could explore if you want to use voices in a chatbot. Now, at this point, our bot has become a real chatterbox. It loves speaking, and while it keeps the conversation going, it's far from perfect. So these are some of the things that we observed after we've implemented our chatbot with an LLM. So first, we realized that it does a lot of what we call, or many people call, botsplaining. So it gives a lot of kind of condescending, verbose explanations that might come as irritating. Often echoes what the user says, so that makes the conversation a bit annoying and repetitive. And finally, it can sometimes get lost in the conversation, especially if the conversation goes for too long. And this is actually a limitation of large language models, as you probably know if you've worked with them. As you start adding things to the prompt and the conversation goes on for longer, these LLMs tend to forget what was said early on in the conversation. So it could happen that sometimes the bot will ask the same question again just because it's unable to see the context that came earlier in the conversation. So these are some of the things that you often struggle with when you implement a chatbot using an LLM. Now, there are lots of things, however, that we can do to improve this bot and to make it come of age, so to speak. So some of these improvements could come from our own observations and experimentation, or they could also come from feedback that we get from users. So I'm going to mention just a few ways in which we can improve our bot and make it more mature. So one of the ways, for example, is by tweaking parameters in the models that we use. So many of the models that are under the hood can have different values for their parameters. So for example, so we could experiment with playing with things such as the temperature of the LLM, or how we detect the end of turn, how long we wait for the bot to speak, or for example, the length of the conversation and so on. So there are some parameters that we can play with. Another thing that we can do is also tweak our prompts. So try to identify areas in our prompt that we think might be causing issues. So for example, if you remember, we had the structure of the different sections that we have in a prompt. We could have a look, for example, at the persona. Maybe the language that we're using is not quite right. Or for example, the structure of the conversation is not well defined, so the conversation could go off track. So these are things that we can play with as well. And finally, we can also try upgrading the models that we use. So as you probably know, these models are constantly updated. So we've got better LLMs, we've got better ASR systems, and so on. So an obvious way of improving the capability of a system is by upgrading these models, the models that we use in our platform. Okay, now when our model becomes a teenager, as it's making its way to adulthood, they're going to be exposed to bad things, and they're going to be tempted to go on with those bad things. So, for example, something that we realized at some point is that even though we try to make our bot as polite and friendly as possible, it could be badly influenced by users. So, for example, some users would attempt to hack the bot or jailbreak the model, as people refer to technically, and therefore make the bot say unwanted things or behave in ways that we don't want. So in order to prevent our bot from doing that, we must implement guardrails. That is, we need to implement rules or mechanisms to make sure that the bot doesn't engage in these inappropriate conversations. And there are many ways in which we can do that. There are services, there are different models, and so on. So whenever we detect that a user is using inappropriate language, for example, we gracefully try to ignore that and bring the conversation back on track. And we also have guardrails after we generate output from our model, from our LLM, because you never know whether the LLM can also generate offensive content, for example. So we have these guardrails in both places. So as a filter to the input and as a post-processing process after we generate the output. So after we've got all of that in place, we are now in a position to create different prompts for different contexts, for different tasks, given our bot different personalities and so on. So that's what we do. We have a series of tasks that place the bot in different contexts. And we also do this for different CFR levels and in the context of work situations and social situations. So that gives us a whole range of tasks that people can complete within our platform. Now, things are not always perfect. Even after we've improved our bots in all the possible ways we can, there's still some highs and lows. So some of the things that we noticed work very well is, for example, the bot is very robust to the input. So even if users try to derail the conversation, the user always brings it back on track and on topic. It's very resilient. So that's a very good trait of the way that we specify things in the prompt and the LLMs work. We also managed to build a bot that's very friendly and empathetic, so it connects very well with users. And as I mentioned, we also made sure that the conversation always stays on topic. So that is something that works very well given the way that we designed our prompts. However, there are things that we still see that are not ideal. So, for example, the bot would sometimes interrupt the user, and this is because there are some issues sometimes in the way that the bot tries to detect when somebody has finished speaking. This is something that not only affects this particular platform, but affects many other platforms out there. It can also happen that the bot mishears certain things, and this is because, as I mentioned earlier, ASR systems are not 100% accurate when it comes to processing L2 English. And also, as I mentioned earlier, sometimes the bot can forget some information that was given early on in the conversation, and that's because LLMs have a limit to the context that they can have in a prompt. So in order to wrap up now, and based on everything that I've mentioned during this talk, I'd like to give some key takeaways, some of the lessons that we learned along the way. So first of all, I think it's essential to team up with experts. If you want to build a platform like this, you need to consider lots of different aspects of what it means to put a platform out there for practicing speaking and so on, all the implications, legal, theoretical, and so on. Also, you have to be aware that you will face lots of technical challenges. So you need to have a very strong technical team and the research team as well. Also, because of the way that these systems usually work, they work with LLMs and with prompts. You really have to start mastering the art of prompting and learning about prompt engineering and so on. You also need to build and evaluate your modules and your capabilities incrementally. You can't really expect to build a perfect platform from the get-go. You have to start building things little by little and evaluate them in isolation many times, and both automatically and with humans. You also have to make sure that you follow ethical principles, because this can have not only reputational consequences, but legal consequences as well. So ethics is really something that should guide your development and use of the systems as well. And finally, definitely get at least a couple of project managers, because these projects can become really big, and it's not something that just a couple of people can take care of. So you really need someone that's dedicated to keeping track of all the stages of the project and so on. So project management is really essential. Now, if you are interested in learning more about some of the aspects of these projects, there is information about AIBC online, so you can scan this code or just follow this link. And the same goes for the ethical framework that we use for building this platform. We have this position paper that's been out there for a few months now, so you're welcome to have a look at it as well. The last thing I'd like to say is a big shout out to the AIBC team, because everything